And the next question. We've got a section of compact bone, and you should recognise everything there, and the types of cell. So if you've watched our excellent Holocaust video, you will know the difference between the blast and the clast. So osteoblasts secrete the bone matrix, whilst osteoclasts break the matrix down. So secrete the matrix and break the matrix down. Or words to that effect. Two structures other than nerve fibres, so we can't say nerve fibres, that are found in the Vertebrae canal. I've seen some answers that have, like osteoblasts or osteocytes or lacuna. You can't have something that's up there also in there. So these are canals, and the clue is really nerve fibres. What else do you need to supply bones? So things like blood supply. So arteries, veins, or if you've done the digestion topic, that would be things like lymph vessels and so on. So artery or arterioles, vein, lymph vessels, something like that. Then we have some diagrams of vertebrae, and you've got kind of some with a big chunk of bone really there, smaller still. So you've got like the lumbar vertebrae at the bottom of the back, that's possibly thoracic, further up, and then up near the top we've got this one, the sort of smaller area of bone, as there's less weight on it. And so actually B is our cervical vertebra. And other bits of evidence, so we've got less kind of solid bone. We've got these two canals here, which are to have blood vessels going up to the brain, and other things different, possibly not as big processes or the sticky out bits, as we've got less sort of muscle size there, more range of movement with kind of more fine muscles rather than big chunky muscles that require something to grab hold of. So we just need to summarize those. So for example, vertebrae canals, wow, what a word, vertebra arterial canals, those to protect the blood vessels going to the brain. And we only need, how many do we need? Describe how its structure is adapted. So we can probably get away with it there, but we can also say small processes for less muscle attachment. For example, small processes for less muscle attachment. These would also allow more movement of the neck. Health workers in Wales have observed a rise in rickets, and it could be down to sort of two things: reduction in outdoor play and fewer dairy products. So we need to talk about both of those and possibly how they interact, and we need to say sort of five separate things. So we've got rickets. So this deficiency, well, deficiency of what? So let's just introduce what rickets is caused by. So rickets caused by the lack or the deficiency of vitamin D or calcium. And let's say maybe one of the more obvious things, so if let's deal with the dairy, fewer dairy products. I think most people know that dairy products contain calcium, for example, and so that will lead to rickets. So if less dairy products, then less calcium in diet. And let's deal with the outdoor play. So outdoor play, we're talking about sunshine. A common misconception is that sunshine, it makes you absorb vitamin C from the sun, vitamin D from the sunshine, but that doesn't happen. It just the light enables the vitamin D to be synthesized in the skin, or just below the skin. So less outdoor play, then less vitamin D synthesized as there's less exposure to UV. So less exposure to UV light, and that's what's going to enable the synthesis of vitamin D. So less synthesis of vitamin D. And then we can also then latch on why vitamin D is important. Well, vitamin D is needed for calcium absorption, so we can now link those two. Vitamin D is needed for calcium absorption. And those are the 5 marks. Next part, we've got some muscle, and micrograph 2 is a close-up. Name the molecules A and B. The mark scheme for these is actually the wrong way around, so if you've got the mark scheme, be careful. But you know that the small ones are the thin fibres and the large ones are the thick fibres, and you know the names of those. So A is the thin, so A is actin, and B, the thicker ones, that is our myosin. Identify the type of section. So that means that this one is cut. So we've got a muscle fibre there, we are cutting down through it like that. So that's our transverse section. If we were cutting along it like that, that would be our longitudinal section. So this one is a transverse section. And micrograph 2 shows a section taken through the outside of the A band. So let's just mock up a quick. So let's have a look. So this will be, that's your A band of myosin, and we've got our actin there, Z lines, and so on. Okay, so this is our A band there, and so they're taking it through the outside of this. So they're taking this through there, and so you can see the actin and the myosin, actin, myosin, actin. So actin, myosin, actin, myosin, so on. And if we did it through the I band, so if we did it through here, then we'd only see the thin fibres, the actin. And so what we need to do is just have, it really doesn't matter exactly how you draw this, as long as they can see that you've only got the thin fibres, and it wants you to label them actin. So it says draw a labelled diagram to represent through the eye band. So only thin and labelled actin. And again, we need a diagram of what's going on here. So there's a very quick sarcomere. So our total sarcomere is there. It says the length of the A band is 1.85. So this is our A band. So that's our A. And the centre of the myosin, that's also mentioned, so that's our there. Okay, so that's our A, and that's the centre of the myosin there. It says our A band is 1.85 micrometers, and the 0.25 at the centre, so 0.25 is there. Okay, and so what we're going to look at is the rest of this. That's what we're interested in. So how many myosin heads are there in each myosin filament? But we need to take off this middle bit. So we want this bit, but not that bit. Okay. So the first thing is to do is go, what's our length of the ticked areas there, and it's 1.85 minus 0.25. So the length is 1.85 micrometers minus 0.25 micrometers, which equals 1.60. Some students have got that wrong. They've said 1.65 micrometers. Okay, and we've got to notice a change in units here. It says there are 6 myosin heads in 40 nanometers. So I'm actually going to change this into nanometers now by timesing that by 1,000. There's 1,000 nanometers in the micrometers. So if we times that by 1,000, you don't need your calculator. You can times that by 1,000 easily. It's going to be, that one is going to be 1,000, and then 600 nanometers. So that's how many nanometers we've got. And we are saying we've got 6 in every 40. 6 heads in every 40. So how many 40s have we got? So we're going to divide that by 40. So we're going to go divide by 40. And again, you can do this in your head. So divide that by 40 is going to be 40. And then, because 4 times 4 would be 16. And then in each 40 we've got 6 heads, so we're going to times that by 6. And that is, and again, 6 times 4, 224, so 240. You do this in your head. So that's now going to be our final answer, 240. So work out the length available, so our total A band minus the middle bit. Convert that to nanometers, and there's 6 heads in every 40, so we want to work out how many 40s we've got in that. So there's 40 times 6, 240 heads. So some good logical maths, not hard maths, just logical maths, and with a unit in there as well. And part E, that lack of calcium. How could that lead to muscle problems? Well, lack of calcium, you could sort of go 2 ways with calcium. If you know about the synapse, so if we're going to talk about the synapse, calcium goes through calcium channels and the arrival of the action potential to enable vesicles containing the transmitter to actually get towards the synapse. So you could talk about that. So we could say less presynaptic vesicles fuse with presynaptic membrane and so less neurotransmitter released into synapse. So you could say that if you knew about synapses, which most of you might not, but we could talk about that calcium. But also for calcium, you could talk about what you do know, which is less calcium available, then less calcium will be released from the sarcoplasmic reticulum to have an effect on troponin. So let's talk about that. So less calcium released by, I can't spell it, sarcoplasmic reticulum, and so less troponin will be activated. And then we're just going through how muscle contracts now. So less tropomyosin changes shape. So you notice that we're saying less and less and less each time because we've got less calcium. So fewer myosin actin cross bridges or actomyosin cross bridges. So myosin actin cross bridges, because tropomyosin reveals the binding site for these myosin heads. And so you could even break this down into more steps, but the end of it is going to be less force generated, or less power strokes or fewer power strokes. And that answers the question that it's weak, uncoordinated, and hopefully you've got your 4 marks in there somewhere.